You probably didn't get a chance to read through Matt's eval, but morning, everyone. We've got people still logging on a few minutes early, and we'll get going here shortly, usually around 4 or 5 minutes after everybody's kind of settled in. So I'll just keep checking in on everyone. For those of you that just joined, we're going to wait just a few more minutes. There's still a number of people still signing in. We'll give it about 2 more minutes and then we'll get started. Okay, we can go ahead and get started. I want to thank everybody for joining this morning. Some of you are returning to the webinars that we host, and some are new. So I just want to kind of explain a few housekeeping things. We do have someone managing the chat that can help answer some quick questions throughout. And then there is a Q&A session at the end. So I wanted to let everybody know that if you have any questions, you can either ask throughout or we can sidebar either at the end or offline when the webinar is finished. So give a little bit of background. Those of you that don't know me from previous webinars, I'm Sean Mantell, owner, CEO of PowerSafe Automation, also application engineer. We put on webinars as part of one of our services that we offer, but we're a turnkey solutions provider offering guarding assessments, the custom design, the manufacturing, assembly, installation, and integration on just about all machine safety projects that you may have in your facility. So throughout this training, we'll explain the goals of the training, applications, do's and don'ts type thing. And then at the end, then when we wrap up, we'll have a copy of the presentation and a copy of this video of this webinar that we can send out to you. And I'm going to turn my camera off. I'm going to share my screen and bring up the PowerPoint, and we'll get started. All right, everybody should be able to see my screen. Basically, this first slide just says this is presented by PowerSafe Automation, but the one important thing is as we go through the webinar, we are focused on engineering your safety. It's very challenging with legacy machines to create a fully compliant engineered system. So you have to sometimes take into account administrative controls, signs, language, different types of training programs, things of that nature. We do not get into that portion of it. So we do everything we can from an engineering standpoint to get you as far and as close to that as possible. So as we go through this, keep that in mind as we're doing the training on engineering on those solutions. This training today is going to be based on 3D safety radars for presence sensing, more specifically the Inxpect brand of the radar. We're going to teach you what it is, how it's used, applications to use them in. I would like to also introduce Andrew Lemke. He is co-hosting. He is on today. He's actually from Inxpect. They provide a lot of technical expertise, help guide us through this new tool that's in the toolbox. Some of you may have come across this device. Some of you may have not. And if you have, hopefully you get out of this training applications you could use this on, maybe some support, maybe some questions answered, things of that nature. So together, between PowerSafe and Inxpect, we're able to provide the products, the service, the solution, all the way through the process from start to finish. The expectations of the training today. This here is we're focused on the 3D safety radar and what controls it. The education is typically for sales professionals and engineers. Could be a plant engineer, could be a controls engineer, maybe someone that's speccing something in there for their facility. Maybe it's the person that's actually tying it into the machine, understanding how it works. Safety professionals looking at this as possibly a risk reduction tool for their machines. And then how it can be used with other safety devices. This is not necessarily a one and done. It can be. And then the proper use and misuse of the technology. And these are the most vital parts to this newer technology. It's emerging technology that has been successful up to this point. If used properly, you have to understand what it is, how it's used. And we're going to get into that today and hopefully answer some of those questions for you. So I'm going to turn this over to Andrew to talk about what the 3D safety radar is.
Oh yeah, good morning, everybody. As Sean said, my name is Andrew Lemke. I'm the application and customer support manager for Inxpect North America. Glad to have everybody on the meeting today. As far as what the Inxpect safety radar is, right? So it's a sensor and control unit, a total system that's designed and manufactured by Inxpect and is the only certified safety radar for industrial environments. Why do we use radar? So, most of the safety devices that you look at today, they're either, optically based or, you're actually stepping on them, say with like a safety mat or something. And instead we're using radar to do that. A couple key advantages to that. One of them is that we do really well in harsh environments, right? So we're able to filter out and ignore anything, dust, debris, smoke, stuff that does not have a large enough signature to possibly be a person in regards to radar. So, that can be falling particulate, whether that's small chunks of metal, sawdust. Smoke isn't something that reflects radar signals, so that's completely immune, things of that nature. Another big thing to always kind of keep in mind with radar is that we're not just looking at simple presence or absence of an object. We're looking for something to be moving, to be alive. And even a person standing still when we're in restart prevention mode will still be detected due to those micro movements you do, the things you do, keeping balance, your chest moving as you breathe in and breathe out. Stuff of that nature is still enough for the sensor to pick you up, but we can fully ignore something like a stationary pallet in the workspace that maybe changes locations, and you don't have to try to shape around that like you would with other safety devices. And it's three-dimensional. So we're not just looking in a singular plane, we're looking in 3 dimensions. So we can monitor, not only at floor height, but say you've got a conveyor that maybe somebody could climb on top of, or a pallet that they're standing on. We can monitor all of that as well. So that's really kind of the basics of why we use radar and what radar is. I'll have Sean move to the next slide, and start a quick video here, and we'll show you a couple different ways that you can kind of use the radar. So a couple different ways, what we call axis protection. So that's really as somebody might be walking up to a machine that's in operation, and you just want to stop it before they get to that hazardous motion, right? So the idea is, right as somebody walks up to it, the radars are always active. As soon as somebody kind of gets into that zone, maybe you're giving a warning beforehand, maybe you need to stop right away. But as they get closer, certainly you're going to stop it. And you're not going to allow that system to start back up again until they exit the area. Once they exit the area, they can reset the system, or it can start automatically if that works for your risk assessment. And the system will just continue to monitor that area. and it'll be fine until they enter that workspace again. Or in this case, as the gantry moves towards them and it sees that there's somebody in its path, it'll stop again. So that's kind of the idea behind access. We'll also talk about restart prevention. And this is getting to be a really big thing within the area, doing presence sensing within a work cell. So think of, traditionally guarded robot cell like you see here. The sensors are going to be muted when all the perimeter guarding is made so that it ignores the motion of the robot, the packages on the conveyor. But once you open the door, of course, that system stops. Sensors are active, as you can see here. And the idea is that they remain active the entire time, looking for those micro movements. Even if an operator's crouched down, standing still, we're monitoring that entire space. Now, the concern being is that, as you see here, somebody else comes along and tries to start the system while somebody's still inside because they don't see them. The system will detect that. The sensors will not be in a safe state. System won't be able to restart. Prevents that incident from happening where you get an operator locked into a system with a moving piece of equipment. Then once they exit, after 4 seconds of seeing no motion, you can restart it and go there. And then kind of the third one for us is what we call kind of your mobile application. So this could be a crane like we see here, could be an AGV or an AMR. This is really helpful in outdoor applications, also some stuff in indoor too. But in this case, it's, protecting crane against running into a person, or maybe even something like a fork truck left in its path, things like that. Once the sensor moves in and sees that object, we're going to stop the system and it won't resume and be able to be reset until somebody removes that object from its path. So kind of the three different subsets of applications that we use there. And different things. And we'll go into some more detail on that, Sean, well, on some of these applications that we've done before. So just another one here also. Oh, yep, go ahead. Um, yeah, AGV tending, things of that nature as well. Allowing that restart, different object in that space, that dynamic change, but because it's stationary when the radar's monitoring the area, we can completely ignore it. So showing some of those options as well. Dynamic configurations on an AMR, all sorts of different ways that you can use it here. So it detects person as they move up. Once they move out of the area, it actually just changes how the radars are being used, uses some other ones and adjusts the fields on the ones that are there to do a perimeter guard at that point. So kind of combining some of those different functionalities that we talked about earlier. Back over to Sean here. Oh, no, this one's still me. So again, it's how does the radar work, right? So as I mentioned, we're looking for not just presence, but we're also looking for movement. So speed and direction of the object and being within the area. And we're going to filter out anything that's stationary. There is an option of, say, somebody adds a stationary object, like they move a forklift into the area and then turn it off and it becomes stationary, that we can turn on to monitor for that as well. And you can configure the detection zones to do different actions, right? Whether it be warning, restart, but we're only looking for that motion. And then, just triggering based off of all of that with different configurations of the sensors. So.
Thank you, Andrew. We'll go on to basically what I'd like to do here is recap a little bit about what he just discussed with access detection and restart prevention, kind of sum that up because there's areas where people use just the access detection and not restart prevention because it's minimum or someone may say, well, nobody should be back there, or I can see over there, nobody's going to restart the machine. I'll check it. Nobody else runs this with me. There could be a number of reasons why. There could be someone in the cage. Maybe someone went to lunch. The maintenance guy was in there working on it. As Andrew showed, crouching down, someone comes back, just closes the door and hits the reset button. If you don't have the restart prevention in there for presence sensing, then that machine could start back up. So the access detection is you are going through the opening where that's detecting. causing the stop condition, and then you have to go back out, hit the reset condition. If you don't add the restart prevention in, then someone else could reset that. If you have the restart prevention, as long as you're in that area, it can't be restarted. So where you may look at it and say, well, that's not required. Well, think in terms of best practice. What could happen in this situation? What kind of equipment am I running? What could the danger be? Is there any kind of other escapement? I mean, there's a number of questions you can ask and answer, but think in terms of best practice and not just what's the minimum I need to do to make sure that I'm following quote unquote the guidelines. And then this is going to be basically an overview of how the system works. You basically have your radar. Once you have your radar in place and you know, is it going to be one radar, two radars? Where am I going to put this? This is what I'm going to use. Then you've got your brains, your muting logic, zone switching. This is what's going to communicate with the safety radar from an intelligent standpoint of here's what I'm going to do, here's what I'm going to try to do, here's the programming, and then a safety rated monitoring device. We like to also use stack lights when we're using radars. Just because it's an invisible area, the zone is invisible and you can't see it. So there's times where, why is my machine not starting back up? Well, there may be something in the zone. A person hopefully is not in the zone, but there could be someone in the zone and it won't restart. The stack light will tell you there is someone in the zone or the zone is clear, so there might be another problem. The other thing with the safety monitoring device, whether it's a safety relay, safety controller, safety PLC, there is no feedback loop for welded contacts in the Inxpect control unit. So to get the proper redundancy checks, you want to make sure that you have some sort of safety relay or safety controller in your circuit, monitoring that for safe conditions. And then you connect that to your output devices, contactors, drive motors, whatever that may be. And then that will give you your safe condition system. You can see here a perimeter guard that could have quite a few blind spots in there. And you can place these radars in strategic areas. So if someone's inside the cage, maybe crouch down back over here, someone closes the door, hits the start button, and then the machine starts up and they've got no way to get out, or they have to crawl under the machine to get to the access door. So this just kind of gives you an overview of what your circuit's going to look like. Obviously, there's a lot of mounting brackets. Where am I going to put this? What's the cabling I'm going to need? But high level overview, this is the componentry and the makeup of your safety system. For machine guarding and functional safety on the input and the output side, we do have other webinars. We just did the machine guarding webinar last week. We will rerun it in the future. It's on our YouTube channel as well for if you want to watch a past webinar. And then if you want to do an exclusive webinar for your facility, we can schedule that in as well. That talks about the machine guarding, the radars, any other devices, electronic safety devices, monitoring devices, to give you an understanding about the machine guarding portion. And then the functional safety side is what are we tying into, and is my controls safe to be able to talk back and forth between the front side and the back side. So we do have those webinars that we host often. Next week there is the functional safety one on next Tuesday, if you're interested in that one. Ideal applications for radars, and there are more than just this, but this just gets the creative juices flowing where you can understand and start to build models of where can I use these. Robotic cells, large envelope machines, harsh environments that could be casting facilities that have graphite dust flying around, could be sawmills with moisture and sawdust, palletizers, depalletizers, the AGVs, routers, there are areas where these are really good, can be tucked away. The biggest one for these radars is going to be the harsh environments. There's because of the technology in it, the dust, the steam, the debris, the coolant, the water. It's typically not a factor, and you can see this area, the dirt that's in here, and this radar is functioning just fine. Then you've got a metal cutting saw at the chips are coming off the blade, cutting through the material, and you can see that once the blade's engaged and it's cutting and it's throwing all the shavings, the radar really doesn't care about that. And then a common application too is the CNC router, making sure that no one is approaching around the perimeter while the cutting head is moving and cutting your materials on that router. So these are just a couple of examples. There are more areas where these can be used, but these are some of the more common ones that we've used these in or have seen these used in. This one I'm going to turn back over to Andrew to kind of go through a few highlights of these on this slide and the next slide.
Yeah, so as with any technology, understanding it and the proper installation is key to getting a reliable system. So, a couple things that you want to look for when you're integrating radar is any signal interference or reflections that you can create. So, one thing radar can do is, especially off of say like a flat metal surface, is it can get a multi-path detection. So, if you've got say a really big flat metal surface in really close to the sensor and you set a long detection field, it is possible that it can reflect off of that surface and then come back towards the sensor and even beyond it, behind it, and pick up somebody maybe standing behind the sensor. Same thing with the signal interference side, that same metal object is going to block signal from going beyond it. So, say somebody's standing on the far side of a big weldment that's a solid, chunk of steel or has sheet metal surrounding it. You may not see that person on the far side because you blocked the signal. This is something that we look at along with PowerSafe anytime that we're looking at systems. So, if you ever have questions on it, get us involved. But it really goes into the proper installation and setup of the sensors. Same thing with vibration. So the sensors, as I said, they're based on movement. So you really want to make sure that the sensor isn't going to vibrate and shake, especially if it's got, say, stationary objects within its field of view. So you want some good solid mounting. You'll see in the pictures in the prior slide Sean showed, the sensors are often not mounted on the fencing, right? Because you don't want somebody closing a door, causing a vibration, creating a problem where the sensors are going to take longer to reset. Another big thing with that, which kind of touches on that last point there of just kind of the mechanical stability and mounting. You just really want to make sure that they're solid in place, that you don't create any of those extended restart times. So the mounting becomes really important for that as well. So just some things to note there. And then with that, when you're installing this, right, as with any safety device, you want to really make sure that you validate these things extremely closely. PowerSafe and Inxpect, we will spend a lot of time and we'll help you guys get an idea of some good settings to start with, but don't just rely on that, right? You're really going to want to, get stuff in there. You might have to tune some things in a little bit, validate that you have the coverage. There's no blind spots, right? There's no object somebody can crouch behind on the far side that sensor won't see them in. Make sure, especially in like restart prevention, that you truly are covering all of that space and that nobody can stay hidden there, because if they can stay hidden there, it's probably also a spot that a person wouldn't see them. So it kind of eliminates the benefit of the radar if you're not monitoring all those areas. So think about, okay, operator could stand here, they could crouch here, they could lay down here, do all of those things. Sometimes you're using it in conjunction with other safety devices. Maybe it's a physical guard, an interlock switch, light curtains. It's not that one technology is always, radar is not going to solve every one of your safety problems. It's another product to help you create a safe system. Um, communication back and forth could be over digital inputs, field bus, all sorts of different things. You're going to want to make sure that how you wire up everything, goes back to the safety standards that you're looking for and meets those, whether it's PL ratings, category ratings, both of them. And then just go through and validate everything, right? As we said, stress test it. Let's make sure that when the system goes in, that it's good. And ensuring compliance, whether it's 13849, 10218, whatever standard it is you're looking at. So yeah, and I'll pass it back over to Sean here.
That's a good segue to talk about the next section with the design criteria. Uh, it is not I'm just going to set a radar in here and it should cover the whole area. I won't have blind spots. I don't have cable management to worry about. There are things that you need to look at when installing these radars. And then also all the way back to the engineering phase of it to make sure you have the right radar, the right application, the right positioning, and a lot of that starts back at the risk assessment. There's different levels of risk assessment. There's a full task-based risk assessment. There's just basic guarding assessments where you're evaluating what the operators may need to get in and out of an area for when you're trying to determine access detection, restart prevention. What is that risk assessment telling you? What should you avoid? What's your exposure? Is that the right application for that? Because if your machine takes 15 seconds to slowly ramp down, you're not going to use the radar in that instance. So that assessment's going to tell you that. And then from there, you're looking to basically recreate your machine. A lot of legacy machines aren't going to have 3D models of that machine. You want to kind of just figure out what is my machine look like and what am I trying to cover so that you can create your detection zones for the sizing, the distance away for your stopping time. Do I need to overlap so that even though that they're invisible, you're you have the ability to find those little nooks and crannies. Where do I mount it? Do I mount it up? Do I mount it down? Where's the cable? Where are the cables going to run so I'm not creating a trip hazard? And then what's the validation and verification requirements when I do install it? Before I install it, commissioning, debugging, those are all factors in the engineering requirements. And then from there, once you know what you need, now you can start planning what you need to use. So as I mentioned, there's different types of radars for the different types of access protection, restart prevention, but also how is the zone covered? Is it a cone? Is it a cube? You can see the slim lines a little bit more like a light curtain. Um, then you can make sure that you're using the right radar for the application, but you need to do all your homework before you can get to that point. And then, as Andrew mentioned, with the specifications and standards regulations, everybody has heard these acronyms, but these are just some helpful numbers if you want to do some additional reading on what the expectations are. Um, Again, you will get a copy of this, so you will have the numbers that you can reference to. And then just a quick note, a few notables. Sensors don't reduce the risk, the systems do. So that's where you have to make sure that you're doing your homework. If you use the radar in the wrong application, you can't expect the risk to be reduced. You have to make sure that you build the system and then use that tool to accommodate for that. Radar support risk reduction when properly applied. And then the documentation validation and training does matter. What auditors are looking for, whether that's an OSHA inspector, whether that's someone like us that's coming in to help with the assessments, whether you're self-assessing, just looking for alignment on the risk assessments, functional safety calculations, validation records, operator understanding. Just because we put in an engineered system doesn't mean that the operator can be blind to what you just did. They should still be educated on what you just did, what to watch for, what to be careful of. That education will certainly help an operator understand their environment much better. And then this is a life cycle map that we've put together that it all starts at that assessment. And then from that assessment, understanding what your environment's like, what you need, what you can't have, what you can have, and then you can create your custom design and start picking the right radar, the right monitoring device, the locations, what's my cabling going to be like, how far is my control panel going to be. All of that can come in the next step, and then you start building the system, and then you take those plans that you've created, create the installation, do the installation and the electrical tie-in, and then just start commissioning through. Make sure you've got all of your zones covered, radars at the right angles, your cable management tied down. Again, no trip hazards, not getting into the viewing area of the radar. You want to make sure that you go through those scenarios. You can even take a handful of shavings and toss them in, and just make sure that what you've installed is working properly. The worst thing you can do is give your operators a false sense of security for them to say, well, there's a radar there, so I'm good. And it wasn't validated when you did the installation. And then there's preventive maintenance, and that's just best practices for all kinds of guarding. But you want to make sure that the radars aren't getting knocked out. Make sure they're not getting hit by anything. The angles are staying where they're supposed to. Nobody's cracked any of the mounting brackets, hit a pole that it might be mounted on, anything like that. So those are all good practice to make sure that you keep your machine guarding top notch, quality, keep your operators safe. So this is a quick life cycle wheel that you can run through these scenarios and just give yourself a highlight of what you're up against, where are you in the stage, and what you might have to tackle. This slide is going to have some Q&As on it, that you may have some questions beyond this training, or this training is answered. These are just some examples of some of the questions other people have asked. And then we have an FAQ section on our website. And then Inxpect also has an FAQ section on their website that you can go and get questions answered. I would recommend that if you have a highly technical question, if you're going to go to the FAQs, just go there for a high-level overview just to get perspective or a quick understanding, but certainly reach out to us to help you really understand the answer to your question. And then from there is a ton of information on our site and Inxpect site, informational blogs, guides, case studies. You can meet our engineers that put these solutions together for you. So a ton of information out there on our site and Inxpect site. Lots of videos at their site, our YouTube site. They've got a YouTube channel. Just tons of information. What I caution you on is you can get crippled by too much information. Please use this as a learning tool just to increase your knowledge base. But let us help you through. Once you understand what you're dealing with, then come to us and we can all work together to put the right solution together for you. And then this is the end of the training portion of the webinar. PowerSafe and Inxpect put this together to hopefully educate you on what this emerging technology is. We hopefully have given you some ideas that you can take back into your facility and say, you know what, I've been struggling with this. We drop paper through here, or sunlight's constantly hitting this area, or whatever they may be, or I have to put this outside of at my sawmill. I just don't know what to do. Hopefully we've given you some ability to do some brainstorming with this webinar. Certainly you can reach out. You'll have my email address after this training, and then sales at PowerSafeAutomation.com comes to me, and then our website is PowerSafeAutomation.com. So at this point, I want to thank everybody for joining the webinar today. Hopefully it was useful. We do have future webinars coming up that you can sign up for. that will be in a couple different areas. Watch our LinkedIn page for those schedules. We have a training page on our website that will give you some future dates. We'll continue to send out email blitzes for those as well. And then certainly don't hesitate to, if you've got a subject or an exclusive that you want to try to do, certainly reach back out to me. So at this point, I'm going to turn it over to you guys to see if there are any questions initially before we end this session. It doesn't appear that anybody has any questions at this moment. If you do, when we get off, certainly don't hesitate to reach out. But again, I want to thank everybody for joining today. Hopefully it was useful, and hope to see you on the next webinar. Thanks, everyone. Bye.